Let's continue doing problems 2.3 from elementary number theory by D.M. Burton. Question number 21a. Prove that if d divides n, then 2 to the power d minus 1 divides 2 to the power n minus 1. If you want to show that 2 to the power n minus 1 is divisible by 2 to the power d minus 1, then we should show that this one is a multiple of this. And we can do this by using an identity. See, 21a. Use this identity. A to the power n minus 1 is equal to a minus 1 times a to the power n minus 1 plus a to the power n minus 2 plus dot 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 plus a plus 1. Okay, let's see how do we make use of this identity for this particular problem. Here 2 to the power n minus 1 is equal to, use this one, 2 minus 1, 2 to the power n minus 1 plus 2 to the power n minus 2 plus dot 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 plus 2 plus 1. This one is n times. And similarly for 2 to the power d minus 1 is equal to 2 minus 1 times 2 to the power d minus 1 plus 2 to the power d minus 2 plus dot 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 plus 2 plus 1. This one is d times. Okay, but it is given that d divides n. If d divides n, okay, n can be written as a multiple of d times a for some a. Let this one be y, not a, for some y. Then 2 to the power n minus 1 becomes 2 to the power d y minus 1. Okay, and here we have 2 to the power d to the power y minus 1. Again we apply the identity. We have 2 to the power d minus 1 times 2 to the power d y minus 1 plus 2 to the power d y minus 2 plus dot 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 plus 2 to the power d plus 1. Okay, see, this one is a multiple of 2 to the power d minus 1. So from here it implies that 2 to the power d minus 1 divides 2 to the power n minus 1. Okay, so now let's come to this one, the second part. Verify that 2 to the power 35 minus 1 is divisible by 31 and 1 to 7. We have to make use of the first one for verifying this one. Let's see. Okay, second part, C. For this one, I can assume that this is of the form 2 to the power n minus 1, okay, where n is what? By comparing, n is 35. And for these two numbers, 31 and 1 to 7, I can write in this form 2 to the power d minus 1. How? Let's see. How can we write this one in this form? 2 to the power 5 minus 1. 2 to the power 5 is 32. 32 minus 1 is 31. Okay. And for 1 to 7, we write in this form 2 to the power. We can write this one as 2 to the power 7 minus 1. Okay. 2 to the power 7 is 1 to 8. 1 to 8 minus 1 is 1 to 7. Now this one is also of the form 2 to the power d minus 1. From the first part, we see that 2 to the power d minus 1 divides 2 to the power n minus 1 if d divides n. So we will make use of the first one. So here, in order that 2 to the power 5 minus 1 is divisible by 31, we have to show that what 5 divides 35, because here by comparing D is 5 and here by comparing D is what, 7. So we have to show D divides N. If we can show this, then we can conclude that 2 to the power 35 minus 1 is divisible by 31 and 1 to 7. So from here, from this part, or D is 5. Does 5 divide 35? Yes, it does. And for the second one, does 7 divide 35? Yes, it does. So we see that D divides N. Okay, so using the first part, we conclude that 2 to the power 35 minus 1 is divisible by 31 and 1 to 7. As simple as that, we have to make use of the first part. Okay, now let's come to the next question. See here, let Tn denote the nth triangular number. For what values of n does Tn divide T1 plus T2 plus ... plus Tn? This one you can check from problems 2.1 question number 3, that your T1 question number 22, your T1 plus T2 up to Tn is equal to n times n plus 1 times n plus 2 divided by 6, and your Tn is equal to n times n plus 1 divided by 2. Okay, we have to find the values of n for which Tn divides T1 plus T2 plus ... plus Tn. So here let's divide T1 plus T2 plus ... plus Tn by Tn. So we have n times n plus 1 n plus 2 by 6 divided by n times n plus 1 by 2. Okay, so these get cancelled. We have n plus 2 by 6 times 2 n plus 2 by 3. Okay, so now Tn will divide T1 plus T2 plus ... plus Tn if this one is an integer. Okay, your Tn divides T1 plus ... plus Tn if n plus 2 by 3 is an integer, and this one will be an integer only if, okay, n plus 2 by 3 is an integer only if the values of n are what? 1, 4, 7, 10 and so on. So these are the values of n for which Tn divides T1 plus T2 plus ... plus Tn. Okay, now let's come to the next question. See, if A divides BC, show that A divides GCD of A and B times GCD of A and C. If I want to show that this one is divisible by A, I have to show that this is a multiple of A. Okay, so to make things simple, let's take the GCD of A and B to be D1. Question number 23. Let D1 be the GCD of A and B. So if D1 is the GCD of A and B, we can write D1 as a multiple of A and B, AX plus BY for some X and Y. For some X and Y. Also, let D2 be the GCD of A and C. So D2 is written as a combination of A and C for some U and V. AU plus CV for some u and v. Okay, now let's take the product of these two. Then GCD of A and B times GCD of A and C, which is equal to D1 times D2, is equal to how much? D1 is AX plus BY, and then times AU plus CV. Okay, let's mark this one as star. It is also given that A divides what? BC. So it implies that BC is equal to A times R for some R. For some R. Okay. So let's see. From equation star, we have D1 times D2 is equal to multiply. We have A square XU plus ACXV plus ABYU plus BCYV. Okay, alright. A square XU plus ACXV plus ABYU. What is BC? AR. YV. Now from here we can take common A, and we have AXU plus CXV plus BYU plus RYV. Okay. See, the product of these two, the GCD of A and B and the GCD of A and C, is written as a multiple of A. So it implies that A divides D1 times D2. That is, A divides the GCD of A and B times the GCD of A and C.